Okay, so this is my video number 8. So in this video I'll talk on the equation of a plane. Okay? Equation of a plane. Equation of a plane. Now in three-dimensional, right, if you have a, let's say this is our plane. Okay, let's call this our plane, and on this plane we have a normal to that plane. So let's call this n with component a, b, c, and we have points p0, x0, y0, z0, and we have any points P on the plane. So let's call this plane M, and we have a point P, x, y, z. So P0 and P are on the plane, and we have a normal n that is perpendicular to the plane M. Alright, so from there we can find of course we can have a position vector R0, and we have a position vector R, and we can find the vector P0P. Okay, we can find the vector P0P. So let me write this in better words. So let a point P0 with x0, y0, z0 lies on M, and n with component a, b, c be normal to plane M. So if P on N, any point, then we can have that if we take the vector P0P and dot product with N that's perpendicular to N, so we have P0 P, since both point P and P0 are on M, and N perpendicular to M, so which means the vector N also perpendicular to P0 P. So therefore if you dot product with N, that will give you 0, yeah, since N perpendicular to P0 P. Okay, so we have P0P here. P0P is vector P0P is R minus R0. So this vector is R minus R0. So therefore R minus R0 dot N, that gives you 0. And you can write this, of course, this is N dot R. This is equal to N dot R0. So this gives you the equation, vector equation of the plane. And if we split this N and R and R0, right, we write that in terms of component. We have A, B, C, and R is we have x minus x, x minus x0, y minus y0, z minus z0. That gives you 0, which is from here. And expand those, perform the dot product, so that we have A x minus x naught plus B y minus y naught plus C z minus z naught that equal to 0. And simplify those, we have ax plus by plus cz, this equal to d, let's say. So where our d is ax naught plus by naught plus c z naught. Okay, so this give us a scalar equation of plane M, of the plane M through point P naught through points P naught and with normal N A B C. So obviously if a point x naught, y naught, z naught is at the origin, or in other words, the plane passing through the origin, then the right hand side gives you 0. Yeah. So if d is 0, which means the plane passing through the origin. Passing through the origin. And if d different than 0, if d is not 0, if you divide through by d, divide by d, so yeah, this equation we divide by d, so what we have, we can write this equation as ax plus by plus cz, that's equal to 1, where small a is capital A, small a is a divided by d, b is b divided by d, and c is c divided by d. So for this type of equation, what we have, the plane, we can find the plane of equation if we were given 3 points on the plane. Yeah, so the plane is determined by 3 points on M. So the plane, the equation of the plane is determined by 3 points on plane. Okay, let's see example. Let's see example. Find the equation of the plane. Find equation of the plane through the point points 2, 4, minus 1 with normal N 2, 3, 4. Then find the intercept and sketch the plane. Yeah. Find the intercept with the axis. Find the intercept with the axis, means XYZ axis, and sketch the plane. Sketch the plane. Okay, so for the equation of a plane, we have a point, we have a normal, So in general equation we have ax plus by plus cz. This is equal to ax naught plus by naught plus cz naught. So our a here is 2, 3, 4. So we have 2x plus 3y plus cz. For z, this is equal to a is 2, x naught is 2 plus b 3, b naught is 4 plus c is 4, z naught is negative 1. Yeah, x naught, y naught, z naught is the point on the plane. So this point here. So this is x naught, y naught, z naught. Okay, just plug in the formula. Then we have this 2x 3y plus 4z. This is equal to, so we have 4, 12 and minus 4, so we got 12. So this is the equation of the plane. Yeah, equation of the plane. For the to find the intercept with x-axis, so for the x-intercept we have what? So we have y and z is 0. So therefore x-intercept is 2x equal to 12, x equal to 6. Then you can find a y-intercept, which is x and z is 0. So we have 3y, 12y is equal to 4. And for z-intercept, we have y, x and y is 0. So that gives you 4z equal to 12, z equal to 3. Okay. So from there, of course, you can sketch the plane on x, y, z. We have on x-axis 6, y-axis 4, z-axis 3, z-axis 3, no, y-axis, sorry, this is y-axis 4, x-axis 6. So here is 6. So we have x, y, z. Just connect this line, that and that and that. So this is your plane. That's your plane. Okay. I have some more exercise, or I'll give you as an example. I give you as an exercise to you. Yeah. Exercise. Find the equation of plane. Find an equation of plane if a point P with 1, 3, 2, Q with 3, minus 1, 6, and R 5, 2, 0 are on the plane. Okay, for this case, you need to solve this equation. So ax plus by plus cz equal to 1. Use each of these points, P, Q, R. For each point, you got one equation. For Q, you got another equation. R, you got another equation. So basically, you have 3 equations with 3 unknowns. So solve for x, for A, B, and C, and plug in that. Then you can find the equation of the plane. Now the exercise: find the point of which. Find the point of which the line with parametric equation x 2 plus 3t y minus 4t z 5 plus t intersect the plane intersect the plane, four x plus 5y minus 2z equal to 18. Okay, so I think you can do that one. Now let's go to the other properties of the plane. Yeah, look at the definition. If n1 and n2 are normal to the plane, m1 and m2, then we have m1 parallel to m2 if n1 parallel to n2, and m1 perpendicular to m2 if n1 perpendicular to n2. Alright, so this is not difficult to see. You can see if two planes are parallel. If two planes are parallel, then obviously the normal to that plane also parallel. And if they are perpendicular, then normal to them are perpendicular as well. Then another definition: angle between two planes. Angle between two planes is determined by an acute angle. So theta is given as cos n1 n2 over n1 n2. Alright, let's see example. Very simple and very straightforward example. Example: find an angle between the plane m1 x plus y plus z equal to 1 and m2 x minus 2y plus 3z equal to 1. And B, find the symmetric equation for the line of intersection L of these two planes. Okay, so to find the angle between this m1 m2, we need to identify what is the normal to that plane. So normal to that plane is given to the coefficient of x, y, and z for each of those equations. Okay, so let's do this one. So from there we can find what is n1 and n2, the normal. We can find n1, which is 1, 1, 1, and we can find n2, which is 1, -2, and 3. Yeah. From this equation, plane equation, normal, the coefficient for x, y, z, so we have 1, 1, 1. The other one is 1, minus 2, and 3. So we have 1, 1, 1, and 1, minus 2, and 3. So therefore, to find the angle, just use the formula directly. So we have theta inverse of cos inverse, we have n1 dot n2 n1 dot n2 over magnitude of n1 magnitude of n2. Okay, so you can find this straight away, cos inverse. So we have 1 plus minus 2, but that's minus 1 plus 3, that 2. So you have 2 over square root of n, that's square root n1, you got 3, and square root of n2, you got 1 plus 4, 5 plus 9, so 14, right? Correct? So 1 plus 4 plus 9, so 14. Then you can use your calculator to find what the value of those things. Okay, so for the second part, you need a point on L and V that parallel to L. Yeah, so you have two planes. So basically you have two planes. So let's say this is one plane like that, and the other plane is, let's say, like that. Okay, we have a line of intersection here. To find this line, this equation of that line, what do we need to find? We need to a point on L, and as well as we need a vector that parallel to that line. Okay, so to find a vector V is just those n1 cross n2, then you got the vector that parallel to that line, which is the line of intersection. Okay, so this you can have I, j, k, so 1, 1, 1, 1 minus 2 and 3. This is easily, you can find that 5 minus 2 and minus 3. And then this line, yeah, this line L, let's say this line intersect with the xy plane. Okay, let L intersect with xy plane, which means z is 0. Yeah, so if that is 0 from M1, so we have x plus y, this is 1, and from M2 we have x minus 2y equal to 1. You solve this equation, yeah, solve that equation, that give you x1, y0. So therefore one of the point on L is 1, 0 and 0. Yeah, this point on L. Now you have the normal to, sorry, you have the vector that parallel to L. Yeah? This vector is parallel to L, and you have a point on L. So therefore you can find the equation of L. Yeah, the symmetry equation. Equation of L, which is given as x minus x naught over v1 equal to y minus y naught over v2 equal to z minus z naught over v3. So that give you x minus 1 over 5, y over minus 2, z over minus 3. So this is the symmetry equation of the plane. Okay, so having done that, the equation of the plane I explained to how to find that, what is also the angle between the two planes, as well as the basic properties of the plane, that if two planes are parallel, then the normal of those planes also parallel. If two planes are perpendicular, then those normal are also perpendicular. So with that, I thank you. We'll meet again in the next video. Bye.